So I wanted to talk briefly about a concept called epistasis. Now that we know how genetic dominance and incomplete dominance and partial dominance work, I want to talk about another thing that can happen here, another idea. And the idea of epistasis, as it's defined by the book, is an interaction between genes such that one gene masks or interferes with the expression of another. Now, you may be thinking, well, what about complete dominance? Isn't that the same sort of thing? And not really. But let's go into the example and we'll talk about why it's not really the same. So we have two genes here, one for blonde hair, one for red hair. If you wind up with this gene, you're blonde. If you wind up with this gene, you're a redhead. And if this was a complete dominance scenario, that would be like, okay, well, there's a dark gene and it's just sort of like coloring over with a darker crayon over this lighter color. But that's not really what's going on here. Let's say there was another gene at play in this case that would make it so that these genes are sort of irrelevant. It's not going to matter whether you have blonde hair or whether you have red hair if you're bald. And so this baldness gene has an epistatic interaction with both of these genes. In fact, with any gene where involving your hair. And so it's not like, oh, we just are coloring over. It's not like one of these genes is dominant over the other. It's making it so that these genes are irrelevant. It is epistatically masking or, again, interfering with these two genes. The example the book gives is discussing these mice. And so these mice can either be what's referred to as agouti or melanistic or black, as the textbook says. But again, none of that makes a difference if they're albino. It doesn't matter what your other genes look like if you don't express any of those pigments whatsoever. And so in a nutshell, that is the idea of epistasis.